This video is going to be all about dreams, hopes, and aspirations. What we want to be. So we all have these dreams. We all have these goals in our heads about what we want to be. We might want to be a famous social influencer. We may want to make YouTube videos, or we might want to be the next Elon Musk and have a space company, or Bill Gates and be wealthy philanthropists, or maybe own a business. So we all have these dreams and aspirations, and for people they're all very different depending on our personality. But for elements, they're all the same. All of our elements, they see our noble gases, and they all want to be just like our noble gases. They all have our noble gases all have that full set of valence electrons, and they're very content, and they don't want to react or do anything like that. And all of our other elements, they want that full set of valence electrons. So you might want to write this down. All elements want is to have a full set of valence electrons. If you're hydrogen, that just means 2, just similar to helium. And for a lot of the rest of our elements, that means to have a full set of 8 valence electrons. So all elements want to have that full set of valence electrons. They all have that dream. So to get this dream to come true, they either have to gain or lose valence electrons, right? And to hit a full set. So we're going to be talking about how they can do that. So we're going to be talking first about electronegativity. And this is how much an element wants to steal an electron from another element. And it's measured on a scale from 0 to 4, where 4 is it really, really wants to steal that electron. 0, not so much. So what we have here is a periodic table in which I colored the different elements' electronegativity. So we could see a low electronegativity would be blue, and as it increases, I colored green, yellow, orange, and then our highest electronegativity will be red. And you can see there's a general trend as we look at the periodic table. Again, our transition elements don't always fit in at the best as they could. But looking at our sides, you might notice that electronegativity increases as I go up the table. So I'm going to say electronegativity increases. Electronegativity increases going up. And then if I look going across, electronegativity increases going this way. And then you might notice, look at my noble gases. They don't have any electronegativity, and that is because, remember what we said about our dreams? Our elements have dreams. All elements want to have a full set of valence electrons. Our noble gases already have that full set, so they have no need at all to steal any more valence electrons. So our element with our highest electronegativity by a lot would be fluorine, followed by oxygen and chlorine and nitrogen. And our element with our lowest electronegativity is going to be all the way down on this bottom left side, francium. So electronegativity talks about how much an element wants to steal an electron. So we have to look at the flip side of that. So The next thing we're going to take a look at is ionization energy. So this is the amount of energy it takes to steal an electron from an element. So let me briefly go back so we could look at the difference. Electronegativity is how much an element wants to steal an electron. Ionization energy is the amount of energy it takes to steal an electron from an element. So they sound very similar, but I want us to think of them like this. Electronegativity is like the offense, or like the action of taking away electrons, how good it is at taking them away. Ionization energy is its defense. How much energy does it take to steal that electron? So they're both in balance with each other. So if we want to take a look at ionization energy by looking at the periodic table, one thing I want to say before we look at the periodic table is having a low ionization energy means you have electrons that are really easy to steal. So if your ionization energy is low, your defenses would be low and it's easy to take that electron. If your ionization energy is really high, it's going to be really, really hard to take that electron from you. So if we take a look at the periodic table, the main differences that we're going to see between electronegativity and ionization energy is now our noble gases are already happy. They're going to have a really, really high ionization energy because they have all those valence electrons. They're going to want to defend them. And we could think the nobles back in medieval England, they had castles to defend what they had. They had castles to defend their dreams and their hopes and their aspirations and to themselves. And these noble gases have really high defense too for their electrons. They defend those electrons. So if we wanted to draw ionization energy, so I'm going to now include ionization energy here. We're gonna cross out electronegativity. We're only going to have ionization energy now. Ionization energy. The only difference is we include our noble gases. And you can see our noble gases have our highest ionization energy. So just like electronegativity, ionization energy increases going up and ionization energy increases going this way. The difference is we include our noble gases here. So our element with our highest ionization energy is going to be helium. And our element with our lowest ionization energy, the easiest electrons to steal, are going to be from francium down here.